Hello, ladies and gentlemen. Today we're going to be learning a couple more types of graphs or charts that you can use to display your findings from your research or the data that you've collected. Some of these may be familiar to you and some of them may be new. So what you're going to need today are your notes, hopefully with a foldable, and then something to write. So far in this unit, the graphs that we have created by hand are the histograms, frequency polygons, and ogives. So we're going to be adding on to that knowledge today with a couple more charts or graphs, but these are the three that we have learned so far in this unit. So a histogram was a type of bar graph, and a frequency polygon and an ogive were a type of line graph. Before we get into the three main types of graphs that we're going to learn today, we should probably talk about the different types of distribution shapes. So in your foldable, you should have the picture already in your notes, but then maybe you want to write what shape it is. So when we have something like this, it's called a bell shape. It's also called a normal distribution. Oh, I wanted to grab my pen. So if you want to write normal, you could put that on there too, but it's also a normal distribution. If we have something where all of our data values are falling around the same frequency or that y-axis, it's called uniform. Then we also have a J-shaped or a reverse J-shaped. So this one was uniform, this one was J-shaped because it looks like a J, right? And then reverse J, some people call it L because it's a reverse J, but that would be this shape. And then there should be four more. We have right skewed and left skewed. And then bimodal, remember mode means occurs the most often. Bi, like a bicycle, means like two. So we have two distinct modes or two categories that are standing out above everything else. And then, of course, the opposite of a bell-shaped would be a U-shaped. So some people ask me when we look at right skewed and left skewed, why this one is called right skewed if more data values fall on the left. Because there's one data point on the right that is going to throw off or skew your data. This right side is where your outlier lies, on the right side. So that's why we call it right skewed. Left skewed means that that outlier or that data point that lies outside of like the normal or the rest of where the data points are falling is on the left side, which is why we call it left skewed. So when we say right skewed or left skewed, we're saying that right or left is where the outlier lies. Because the outlier lies on the right side, then it's a right skewed distribution. Because that outlier lies on the left side, then it's called a left skewed distribution. So hopefully you have all of these shapes and distribution shapes labeled, and we will work more with these types of distribution shapes and labeling them and why they're important as we move on throughout this unit and units to come. Okay, for the rest of today's lesson, we're going to talk about the three different graphs that we're going to create. The first one being a bar graph. Hopefully you've seen a bar graph at some point in your mathematical careers so far. When we talked about comparing bar graphs to histograms way back, we said that a bar graph uses qualitative data and a histogram uses quantitative data. Your bars can be represented vertically or horizontally. So sometimes, just to switch things up, people make a bar graph going horizontally, like the one pictured on the left here. So you can switch your X and Y axis if you absolutely want to. The bars do not have to touch. Most of the time they don't, to show the different categories of that qualitative data. And then, of course, with any graph, not just a bar graph, we should always label our axes appropriately with labels. Okay, this is probably one of the new charts that you've never heard of before, but a Pareto is pronounced like a burrito, but with a P. A Pareto chart also is a type of bar chart that uses qualitative data. They are arranged from highest to lowest. So it's basically the exact same thing as a bar graph, with this one contingency making it different and calling it a Pareto chart. So using that same graph that we had over here, auto, bus, trolley, train, walk, how people get to work, we organized it from highest to lowest, going left to right. We went from highest to lowest in our frequency, and that's what made it a Pareto chart. So again, our scales should always be consistent on our X and Y axis. They should always be labeled. And then as well as a bar graph, our bar should be the same width so it's not a misleading type of graph. Our last chart graph that we're going to learn how to construct today is a pie chart. This should probably be another chart that you're familiar with, including that bar graph. Pie charts, I mean, up here it says that you should use qualitative data. There are plenty of people that use quantitative data as well with pie charts. I think it's suggested to use qualitative data rather than quantitative data because when we look at those pie slices, it's easy to look at a category like 50% of the people that were, or the employees that were studied are married. 27% are divorced. If we had quantitative data, we would be saying like 50% of the people that we studied were a specific number. So I think when you have numbers on top of numbers, it can get a little confusing. But as long as you visually represent your pie chart with good labeling, then you can also use quantitative data. You don't have to only use qualitative data. Okay, so how you would construct this by hand is by using a protractor, and you would have to use that relative frequency in order to come up with the degree slices for each of those pie slices, or the degree measurement for each of those pie slices. But quite honestly, when we talk about all three of these graphs, the pie charts, the Pareto charts, and the bar graphs, and histograms even, and frequency polygons and ogives, we don't really construct any of those graphs anymore by hand. We always use, in the real world now, we use different types of software or different types of technology in order to create all these graphs. So what we're going to do today, instead of doing examples in our foldable and doing them by hand, we're going to do some examples together. So if you want, you can pause this video to get your tab open to Google Classroom to open up these examples that are attached in Google Classroom. And so there's a whole entire tab in this Google Sheet, the examples that we're going to go through together. And then there's also a tab that will be our homework when we come back to class together for you to try on your own. But I'm going to show you how to create not tables, excuse me. I'm going to show you how to use tables to create different types of graphs and charts in Google Sheets. So hopefully you have it open by now. If you haven't, you should have paused the video and done so, but we're going to move into finding a bar graph, or creating, excuse me, a bar graph, a Pareto chart, and a pie chart. So first we're going to start with a bar graph. You'll see that the table that you want to create will have a title, like the continent and the number of roller coasters on each continent. And then all of the categories are below with each of the continents, and then of course our frequency for the number of roller coasters. So I'm going to highlight all the information that I want to go in my graph. I'm going to hit Insert, and then I'm going to go over to Chart. And then for whatever reason, it always defaults to a pie chart right away, but I want to try a bar graph. So I think it's called, yes, in Google Sheets, it's called a column chart. You could also do a bar chart horizontally. Either way, these are both bar graphs, whatever you want. And then Google just always defaults the title to the two titles of your axes versus each other, like number of roller coasters versus continent. So let's make a better title for our graph that says number of roller coasters on each continent, and make sure when you title things that it's appropriate, labeled with capital letters and such. And then everything else, just double check. We have the appropriate label for the continents down here, and we have the number of roller coasters for our frequency over here, so it looks good. I'm just going to make it a little smaller so that I can bring it down over here. I'm just going to make it a little smaller so we can see everything. There we go. Okay, when it comes to creating a Pareto chart then, you're going to do the exact same thing, except now before you select your table of information, you personally have to go in and manually do the table and create the table. So you have to organize the table from highest to lowest. Like Google's chart options won't do that for you. You have to create the table yourself that way. So we're going to use the same set of data with the number of roller coasters on each continent, but now we're going to do them from highest to lowest because that's the only difference between a bar graph and a Pareto chart, right? So in my number of roller coasters, my highest number was 643, so that's what I'm going to type. And then that continent was North America. After that, it should be Europe with 413. After that, it is Asia at 315. And then South America at 45. Australia at 22. And Africa at, 17. So now we have organized the same information from that bar graph into a table that organizes it highest to lowest. So now I'm going to go back to insert chart and I'm going to go back to the bar graph. So now it is the exact same thing, the exact same process. Number of roller coasters on each continent. There we go. And we have it organized from highest to lowest, which makes it a Pareto chart. Easy enough. Perfect. Okay, I'm going to scroll down now to our next set of data or table. These were, all of these examples are kind of taken out of context, but this particular data set that I found was most popular snacks for the Super Bowl or something like that. And it was a long time ago, like maybe 2012, 2011. Anyway, so we're going to make a pie chart using this information. So we're going to highlight all the information that we want to go in our chart. And it's already a pie chart, so that'll be great. Pie charts are always labeled funky, so just make sure your labels are making sense. So this is going to be favorite Super Bowl snacks from, we'll say, I think it was 2011. And then it has all the categories like potato chips, tortilla chips, pretzels, popcorn, nuts. Perfect with the percentages. It already did all of that for us, so we didn't have to worry about it. When you are done with all of your graphs, you can always go back in and play around with the settings in the chart editor. So you can change the color of your pie slices if you want. You can change the title here rather than up here. There's so many different ways you can do things. If you want a different font style, font color, you can make any kind of adjustments over here. And you can play around with those settings. And maybe you even know a quicker way. Maybe you guys are way better versed in Google Sheets than I am. So maybe you know a quicker way on how to make all these charts. But there we go. So you're going to be doing the same process for the homework examples, but you're going to organize your table first with these blood types from the Canadian Army applicants. And then it's going to ask you to create a bar graph, Pareto chart, and pie chart, and then just paste them below. So that is the examples for today. And we're going to be actually for the rest of this unit, we're going to be making all of our graphs digitally rather than by hand because nobody does graphs by hand anymore. So with that, I want to thank you for taking good